Of all the limit indeterminate forms, 1 to the infinity is probably the most controversial one. At least it is the one I have seen students argue about the most. In this video, I want to explain why 1 to the infinity really is an indeterminate form, and why our intuition about it may be a bit off. First, let's remember what it means to say that 1 to the infinity is an indeterminate form. It means that if I am trying to calculate a limit like the one here at the bottom, the limit of a function f of x raised to the power of another function g of x, and if I know that separately the limit of the base f is 1 and the limit of the exponent g is infinity, if I know those two things, then what can I say about the full power? Well, then I cannot draw any conclusion about the full power. The limit of f of x to the g of x under these assumptions could be anything. That's what it means to say that 1 to the infinity is an indeterminate form. No more, no less. Notice that at no point am I actually raising the number 1 to any power. It's going to be numbers close to 1 raised to an exponent that is large, that's all. Probably the best way to prove this, the best way to prove that under this hypothesis I cannot draw a conclusion, is to offer a battery of examples where the hypotheses are true, but the outcome, the final limit, takes many different values. Let's do exactly that. I'm going to construct a family of examples the following way. Let C be any real number, and I'm going to look at the following limit. The limit as x approaches 0 on the right of e to the x raised to c over x. I think of this as a function raised to another function. So let me look at the two functions separately. As x approaches 0, e to the x is approaching 1. And as x approaches 0 on the right, c over x is going to be approaching, well, if c is positive, that will be infinity. If c is negative, that will be minus infinity. And I'm going to exclude the case when c equals 0. So altogether, for every value of c, I have a different example, and all those examples are of type 1 raised to either plus or minus infinity. So what's the value of this limit? Well, the nice thing about this example is that we can compute it very easily, because I can use the properties of exponentials and rewrite these functions as follows. E to the x raised to c over x is simply e to the x times c over x. And now I can simplify this. Turns out that this is just a constant function, so the limit is e to the z. So there you have it. By choosing different values of c, I can construct examples of limits of type 1 to the infinity that have many different values. In fact, I can make the final limit be any positive number I want. So this justifies saying that 1 to the infinity is an indeterminate form. Just from knowing that I have 1 to the infinity, I don't know what the final answer will be. So why is it hard to accept that 1 to the infinity is an indeterminate form? I believe the answer comes from taking 1 to the infinity a little bit too literally. It's not 1 to the infinity, it's numbers close to 1 raised to very large exponents. Look at these 5 examples here on the top. If we were computing the limit as x goes to infinity of 1 to the x, this one definitely would be 1, because this is just the constant function 1 in disguise. Now, let's compare with the others. If I'm computing the limit as x goes to infinity of 2 to the x, then we know that that's going to be infinity. And the same is true for any other constant base that is greater than 1. 1.01 to the x, as x approaches infinity, goes to infinity. It just goes there much slower. It takes a long time to get large. On the other hand, the limit as x goes to infinity of 0.1 to the x, well, that is 0. And the same is true for any other base smaller than 1. 0.99 to the x, as x goes to infinity, also goes to 0. It just takes a long time to get close to 0. However, in practice, when I look at 1 to the infinity, I don't have a constant base. What I have now is a function that changes and is approaching 1, perhaps above, perhaps below, perhaps both. And I have another function, g of x, that is changing and is getting large. So what's happening to f of x to the g of x? Well, on the one hand, since f of x is approaching 1, and 1 raised to anything is 1, then we could say that the base f is trying to make the power get to 1. But on the other hand, since g of x is changing, and g of x is approaching infinity, well, if f is slightly greater than 1, then g of x is saying anything is slightly greater than 1 raised to infinity is infinity. So g is trying to make the answer infinity. Or, if f of x is slightly smaller than 1, g is saying anything smaller than 1 to infinity is 0. So g of x is trying to make the answer 0. And there lies the tension. The base wants the answer to be 1, the exponent wants the answer to be either infinity or 0. That's why we get an indeterminate form, and that's why the actual outcome, the actual value of the limit, depends on the specific example.